Hello, everyone. Welcome to the Microdesk webinar series. My name is Ravali Ravulapati, and I'm the Marketing Manager for the Western region. Welcome to today's webinar, Let There Be Daylight, a Practical Approach to Ecotect and Radiance. If I can go to the next slide, I'm going to give some information about Microdesk for those of you who aren't familiar with us. Microdesk is an Autodesk Gold, Oracle, and Google partner. We provide technology training and consulting solutions for the AEC industry. We have 12 offices located throughout the East and West Coast with a staff of over 90 consulting and technical specialists. Over the next hour, we'll take a look at a special presentation designed to assist you in understanding the real benefits of using Ecotech's daylighting performance tools and how through the use of Radiance you can provide a more detailed radiocity-based analysis. Radiance is the industry standard for detailed daylight analysis and can help you design teams better, understand lighting impacts both qualitatively and quantitatively. We'll explore how Radiance, when run through Ecotect Analysis, can generate images to calculate the quantity of daylight and predict glare. Also, you'll learn how to test a variety of alternative ski conditions, times of the day, and glass tints to see how various daylight scenarios will impact a space or building. Presenting today's session is Microdesk Solutions Specialist, Leo Salce. Leo is an architect by trade and a senior technical specialist with Microdesk. He has expert knowledge of the building informational modeling process and advanced visualization and sustainable design. He specializes in providing BIM consulting and training, as well as design content and advanced model creation for architectural and engineering organizations nationally and internationally. He's a lead AP for building design and construction and a registered architect in the Dominican Republic. Leo can frequently be found speaking at industry events and conferences presenting on green and sustainable design techniques. Just a few logistics before we begin. In order to minimize any background distractions, you're all on mute for the duration of the session. If you have any questions during the presentation, please type them in the question area of the webinar toolbar to the right of your screen. Leo will address as many questions as he can at the end of the presentation. And if we run out of time, I'll be sure to provide you with our contact information so you can follow up with us. And now, I'll turn it over to Leo.
Thank you, Ravali. Well, good afternoon, everybody. Welcome to today's webinar session on Ecotect and Radiance, a practical approach. Let there be daylight. Today's presentation is focusing on how Radiance can be used within the Ecotect interface to produce actual practical data that you can apply for maybe LEED certification and maybe just studies early on in the design. So it's a very useful and practical approach that we can take on using those particular tools. And the best part is that they can be integrated into your design, current design application, whether it's AutoCAD, Revit, or whichever other design tool. So the first thing that everybody would ask themselves is if you're talking about daylighting analysis to do or be performed in-house without outsourcing to a consultant, is where do you begin? Well, there's a few things that you can do in regards to optimization that affects daylighting, and that you can see right here on this slide, which are building orientation. You can start testing that early on. If it's a new construction project, you can start working with the optimized envelope, optimized shading, the building massing, and optimized glazing. So those are things you can do in your own design native program, whether it's Revit or AutoCAD, et cetera, et cetera. And again, Ecotech gives you the ability of even going further and use that data. And if you would like, there's a feature for shading design that allows you to work with shading devices, which is a very, very cool tool that is part of the application. Now, a few things that you know about daylighting is that the idea is, and I don't know if you knew it, but it's actually one of the most common ways for designing energy efficient buildings. Daylighting is a very common approach towards the energy efficiency, whether it's for LEED purposes or just for making the building green in regards to being more sustainable. And again, you can follow some rules of thumb in regards to sun position and taking advantage of natural location of shading, or just optimizing by using artificial shading. But things you can test and actually run some simulations within the Ecotect interface. That's something that I'll talk about today. So a few things that you can do, and so everybody knows, it's that you can go up two ways. in regards to performing sustainable design analysis. And there's quite a bit of simulations that you can do today with several tools. The purpose of this presentation is on Ecotech and how you can use Radiance to go a little bit beyond what you can do with the default application. So you can go about it with the geometry export from your BIM application, or if you're working with a CAD file, as long as you have some geometry, three-dimensional, you could use that even for analysis for daylighting purposes, and I'll mention that in a second. So two ways that you can go about certain analysis is the full 3D geometry, which I'll mention some of the formats, or space-based geometry, which requires a little more information in the model. But whichever you choose, it's good that you know what kind of the capabilities are, and there are some requirements, of course, that you need for specific simulations. But if you're talking about space-based models, a few things that you should know is that most common format to work with is the GBXML, and although it can be used for daylighting, it serves purposes for more advanced simulations like energy demands, transmitted solar radiation, thermal performance, and so forth. The GBXML is a scheme format that it was established a while ago for allowing multiple applications to talk to each other. So it means that if you were using your design tool, how do you get to your analysis tool, and retain as much information as you can from one to the other without the loss of properties and information. So that's what that format became very popular, because it actually allowed for somebody that was designing to bring in that format, that amount of information that was necessary to be used in the simulation tool. Now the problem today is that it requires for you to understand what properties come from the program, from the design program to the analysis tool, and each one is different. So if you're using Ecotech, there's so much information that comes in from a program like Revit, for instance. So it's important that you know what comes in, and for that I would always recommend assessing or getting some professional consultant. In regards to what we're talking about today, which is daylighting, you can use the DXF approach, or pretty much any format that produces a 3D geometry format that is native. I'm mentioning DXF because it's one of the ones that are more popular to bring it into Ecotech. But any other formats like 3ds, or you can work with several other formats actually. But this is one of the most common ones. But in regards to geometry-based, it allows you to perform certain kinds of analysis that don't require a lot of information in the model, such as shadows and overshadowing, things you can do in Ecotech, airflow and ventilation, which for those of you who don't know, Ecotech can export to programs that support CFD simulation, but right now Autodesk actually has a whole set of tools that are now available for people that like to perform either computational fluid dynamics simulations that have to do with either ventilation, that could be for buildings, to recreating how a particular equipment or manufacturing object can be, can have airflow circulating through the object. So most commonly for architecture will be for a building to perform simulation, but Ecotech doesn't perform that on its own. It requires an additional application. You can also use the DXF format, which is the geometry-based option, for external solar availability. So it means that you can calculate how much sun you have available for certain areas of your building, whether on the inside or the outside. Also, I don't know if you know, but DaySim, which is a tool that also complements, Ecotect and Radiance, it serves the purpose of calculating the amount of daylight available in the building. So it's if you want to go a little more accurate, and not really accurate, but if you want to have more control, or maybe more ways to report that kind of information, you can use that tool, and it's also free. And I'll mention how those integrate. And finally, you can do lighting and daylighting analysis. So if you just have a piece of geometry that represents a section of your building, or if you have the entire building that you want to analyze, you can actually add in Ecotech artificial lighting, and you can perform exterior lighting for daylighting analysis simulation. So that being said, simulation setup, what is it required for you to start performing anything in-house? Well, first it requires a software. It requires for you to first you use the daylight simulation tool to create value for the design process. So what tool do you recommend for that, or what tools are recommended for doing this kind of thing? Well, it depends on what you have available. in regards to design applications. So if you have a program like Revit, if you have a program like AutoCAD Architecture, or something that exports to a three-dimensional object, whether there is a GBXML or a DXF, you can use those and find a tool that works well with those formats. So Ecotech is one that is being proven to work very smoothly. And although depending on the complexity of the project, it may require some tweaking, it works pretty well under some well-established workflows. Also, you have to make sure that you have the end in mind before you start in regards to picking the right simulation tool. And also, and very importantly, use the validated simulation tool. So what's the purpose of using a tool that can perform this simulation if it doesn't comply with the maybe codes and requirements for specific rating systems like LEED, for instance? So in that case, you have to, that's why I say it's always good to have some kind of assessment up front, discussing what the goals are. That way, before you make any sort of investment to perform these kind of things in-house, which definitely have a lot of positive savings, but before you do anything and commit to a particular software or tool, you have to make sure that you know exactly what the goals are and what you have in mind, and then based on that, you can find out, because there's so many tools out there that can perform daylighting today and can perform any kind of other simulations like energy, natural ventilation, and so forth, that you can go in so many directions, and it's easy to get lost. So it's good that you know what the end is, to have the end in mind before you start. Also, you have to have an understanding of the assumptions and limitations of the simulation models and performance metrics. A lot of people think just because they buy a piece of software that there's an easy button that they click on and they say if it passes or if it fails. Yes, it's getting to that point, and some tools today can give you almost a report that will tell you, yes, you fail or you pass for rating like LEED, for instance, for the 8.1 credit for indoor environmental quality. But it's important that you know what's behind the scenes and what's happening to actually interpret that data. So not just saying, yes, you pass or you fail, but what is actually the metric and how's that performance being analyzed. So that's why I like the workflow with Ecotect and Radiance. Although Ecotech is not really a validated tool on its own, it requires Radiance as an approved and validated complement tool. The two work has one validated option, so you can use that for lead submittals. And I know for a fact that a couple of consultants that I work with use that workflow with Ecotech Radiance and sometimes DASIN to submit for lead documentation and to actually get the credit approved for the indoor environmental credit 8.1. So the other thing you need to know is that you should always build your model for simulation as simple as you intended the intended use allows, and if possible, divide it in pieces for a detailed analysis. So depending on the type of simulation, especially daylighting, you don't want to bring in every single thing on the inside like furniture. You don't want to bring in all the components that you can see on a 3D model. So basically you just have to follow the metric performance. So for instance, if all you need is a grid above the floor, a certain base size that will tell you the full candle level maybe in an area that is occupied, maybe you don't care about having furniture. But if that's something important for you to know, let's say glare, because you need to have a plasma maybe on a particular wall, then it depends on what the goal is. And that's why I said you need to know that in mind before you start and decide what tool you need. So again, Ecotect and Radiance work has a validated tool that can be used for lead purposes if that's what you care about. I know of a lot of architects that use this tool just for early design concept analysis, so they know kind of where the shadow is going to be and also how much light is going to come in and through a particular area at a given time of day on a given month or year. So you can use that for validation or for actual meeting requirements. So Ecotect Analysis and daylighting. On its own, without using Radiance, and I'll explain what Radiance is, Ecotech can go about daylighting analysis several ways. Daylight factor is one of the things that you can do within Ecotech, and it can be done 3 different ways. Point analysis, which is using a perspective camera to see how many points and how much lighting value is coming in through those different points that you set up. Also, you can have a point analysis using a sun path projection, so you can see the amount of lighting coming in through the sun path. And also you can display sun rays, so you can see the amount of lighting coming in and maybe section an area like probably part of the building where you have blinds, and you can see what happens if you change the rotation of the blinds at a certain time of day to see how much light bounces off the blinds, if it's a shading device projection, for example. And finally, the most common one, which is a geometric analysis using a grid or sensor points. But the grid is the one that is one of the options that LEED requirements use. So for LEED, you're required to have a grid that is analyzing all the points a certain distance above the floor on a given time of year, on a certain time, on different times of day. Let's say 3 o'clock, 9 in the morning, and then you can analyze the amount of foot candle level with a minimum threshold between, let's say, 25-foot candle to above 500, within 25 and 500-foot candle. And again, that's something that you can analyze within Ecotech. So those 3 different ways that you can approach it, as you can see on this slide, you can see the point analysis using the sun path. You can use the perspective points, which you can define as you're working. And also you can use the grid or sensor points that you can see on the left side on this slide. So that one, I'll tell you how you can use it to represent the data in a usable format. Right now it's color-coded, and although it gives you a nice representation of how much light you're getting through certain openings, windows, and so forth, I'll tell you how you can actually interpret that data for purposes of, let's say, LEED certification. So that being said, there's a few things you should consider in regards to daylight factor. Well, first of all, the type of the reference building, so it means that are you using the grid? Second, the window head or the actual opening, is that something that is because you're using the amount of lighting coming in through the glass. Also, another thing that it goes hand in hand to that is the glazing type. So if you have a double panel glass wall window, how much light does it actually go through on those instead of having 3 panels or 4 panels and so forth? And depending on, of course, the plan layout, you got to make sure that the grid is actually enclosed in the whole area. So there's several things that you just take into consideration when you're setting up the grid. And again, when you're doing the daylight factor, you can perform, you can do the whole thing as a fully glazed value. And although it doesn't take glare and solar gain control into account, you can start testing certain things right there, even if you don't have any walls and windows defined yet. So you can have, just like corner walls, for instance, you can have just a whole plain glass and start performing full glaze analysis if you need to. Now, the other option is resulting building design form is improved from an energy standpoint, and I mentioned that. So you can start testing the device louvers, light shelves, static shading, and so forth, even vegetation. So if you start putting vegetation at certain, in certain locations of your project, you could see if that the natural shading can affect the amount of light coming in and so forth. So if you break it down, what do you need to perform a daylight simulation? This is actually it. First, you need a building model, and that can be built within Ecotech, or you can build it on your design tool. So it could be Revit, it could be AutoCAD, it could be whatever application. You need a sky model. Ecotech gives you that. You need an area of interest, which is the analysis grid, and a simulation algorithm, which is what the software is for. So you use the program that it will perform the simulation based on all these different algorithms and formulas. Based on some performance metrics, then you can use that data. So the building data is going to come with the geometry, material information, artificial lighting, shading devices, the landscape around it, and any reflectancy if it has any. And of course, there's going to be sky conditions. That includes the geographical site, data for the time and day, and the sky luminosity. And that's all something that you define in both softwares, whichever you use for designing, or if you want, you can do it all directly in Ecotech. Actually, it's a shame that some people end up recreating the model in Ecotech sometimes because they find a lot of problems in the way that it translates the geometry. But it's just, there's certain things that you should do, kind of best practices that you need to follow in order for those to be successful. So depending on the simulation that you're doing, in this case daylighting, you know, make sure that you do things in a certain way. And the problem is that there's not really like a lot of white papers or information that will tell you what are the steps. Well, I'll tell you some of the things in just a minute. But you know, there's certain things that are pretty generic, like always model your model as if it would be built. In regards to never leave geometry kind of gaps on the geometry. Make sure that the model is airtight, so there's no light that kind of getting out of the areas. Also, make sure that the model is not over-modeled. So there's little things that you see, kind of generic best practices for maintaining model size, but they are actually a lot of them apply to generating a model for analysis, in this case for daylighting. So how does Ecotech perform the daylight factor calculations? Well, there are 4 methods. Actually, actually 4 if you include radiance. So there's the default daylight factor using a formula by lines. There's original split flux method, which is something that is using a protractor, which I'll show you in a minute. There's the split flux method default in Ecotech, and ray tracing and radiocity with radiance, and I'll mention those in just a moment. So what does that mean? What are all these concepts representing? Well, for the split flux method, which is default in Ecotech, this is a method that represents points, pretty much representing rays that are approximately equal solid angles of sky, and how much of those are getting into your room based on the opening that you have. Now, the thing about this is that it's not approved by LEED, so it's good for analysis that you just want to test. If you don't use radiance, you can use it kind of to see maybe comparison values to see what happens if you alternate and change maybe the angle of the sunshade device, or maybe the opening width of the window and so forth. So there's a lot of things that you may not really need to know in regards to how things are calculated, but just so you know that these methods are just available through wizards. When I say wizards, they're usually available as a simulation option on the menu, where you can say, I want to do a lighting analysis, daylight factor, and then just it will continue to ask you questions. And it usually requires for you to set up a zone path or a grid if you need to. So again, these are just different methods that are available. This one, for example, takes into consideration the luminance of the sky, reflectance of the material, and relative surface angles and glazing transmittance. All of that stuff, a lot of them can be preset in Ecotech in regards to material libraries that have a certain amount of transparency, reflectance, and so forth. And I'll mention that in a second. One thing that you should know is limitations. So to be compliant, Ecotech cannot consider multiple reflections, so therefore it underestimates indirect daylight. So you may see that there may be certain areas where the light is off, and if you need multiple surfaces to illuminate a space, that's why it actually works well with radiance, which takes advantage of other. It actually takes advantage of the whole model and how everything is set up, and will give you a method of radiosity to calculate this information. Anyway, the split flux method requires the design values. This is representing the design sky values, horizontal, that exists 85% of the time between the hours of 9 and 5 through working years. And it's really representing worst case scenario that you can design to and be sure your building will meet the desired light levels at least 85% of the time. So again, this is one of the methods. It's not really the most common one. The most common one is the one that uses the grid for interpretation. But other ones are the sky factor and VSC, which can calculate the sky factor and vertical sky component using the sun path diagram and points where you can define anywhere on the space how much light levels you have inside of any room. So it's very interesting. Now, in regards to materials, I mentioned that it's important to have geometry. It's important to have the right material assignment, especially if you have window glazing of a certain type. But the good thing is that Ecotech has a library, and that library can be easily customized. So what you could do is you can simply, by default, if you translate from, let's say, Revit into Ecotech, some of the things are going to be mapped automatically. So a wall will know that it's a wall, a door will know that it's a door, but the values per se are not going to come in. So you have to know, once you define the windows, you can select them all, or by window orientation, and then select the type of window that you want, or the type of wall. And one thing that I find very cool is in the material library, I don't know if you see on the top left, you can highlight the information that is specific and critical to be filled out for a simulation that you want. So for instance, for lighting analysis, as soon as you select only show me parameters that are relevant to lighting analysis, you'll see that they highlight in pink. That's very cool, because you can do maybe other kinds of analysis and not worry about certain parameters that you don't care about without having the expertise. So just make sure that you have those values properly set up, as they would be realistic, the representation, and then you can get a more accurate result at the end. Anyway, now that we get to kind of the default process within Ecotech, then why would you use Radiance, and where can you get it, and how much does it cost? Well, first of all, when you look online for Radiance, you're going to see two things. You're going to see two versions of it: desktop Radiance and one called Radiance on its own. The desktop Radiance is the one that you want, and it's the one that includes libraries of materials, glazings, so forth, and it works well with programs like Ecotech. It actually runs within Ecotech as an engine, and you don't even see anything kind of processed. It has its own interface for viewing the results, but if you think about it, it's kind of running within the program, and it can be interpret the information in Ecotech. Also, it's free. So it was developed by the Berkeley Laboratories in California, and it's still free. And because it's accessible by all, for all. It's the latest version, I think it was 10 years ago, but it means that it hasn't changed because it works the way it's supposed to. So another thing that you should know is that the default, if you ever run into the one called Radiance, that one is a suite of programs that run on a unique software. So you'll see that there's two different things that you'll run into if you Google it. So make sure that you got Desktop Radiance, which is the one that works integrated with your DesignCAD software and also with Ecotech. Ecotech and Desktop Radiance, like I said, they run within each other, and there's also a menu that will allow you to perform the simulation within Ecotech, just like you do any other simulation through a wizard. I'll mention what that means in just a second. This is an example right here of the viewer. So you have a report at the end of the different camera setups that you set up in Ecotech, and then how you can analyze this information. And it's very visual. It actually processes a rendering, and that rendering can be represented in pseudo color, it can be represented in contours, can be represented in dots. Those dots can be representing different values of light levels. So again, Desktop Radiance is the one you want, and Ecotech in this case serves as a visualization platform for that data that is generated by Radiance, and then it can be used to see the results in Ecotech on a grid, for instance, to maybe calculate the amount of square footage that is being applied, the amount of daylighting, and I'll show you in just a second. So this is an example of a camera view in Ecotech. Once you bring in the model, let's say this is one coming in from Revit, you have a very simplified version of it. You have all the different windows and openings, and the sun is already set up at a certain time of day, specifically with the right orientation and so forth. So once that's set up, what you do is you go through a 9-step Ecotech wizard. So pretty easy. You just go to a menu called Run Analysis, and then in there you'll see one for lighting analysis. Once you're in the lighting analysis option, you'll see that it will give you the option to run it within Ecotech or to export it to Radiance for more detailed analysis. So if you have anything more complex or you want something more accurate, then you want to go with the Radiance option. I'll tell you what you need in order for you to do that. So the second thing is that if you go through the wizard and you hit next, is how do you want the presentation of the results? A lot of times you want to generate the images in Radiance, but you also can calculate values for objects or grid points, then load them back in Ecotech. So it kind of creates like a spreadsheet that you can later on reuse. So it will give you different options to interpret the information. You can open also the Radiance control panel. Radiance has a control panel that is its own user interface, and it's not complex, but I'll show you how it looks. It looks pretty intimidating, but it's really not that complex. The next step is defining the luminance distribution. So right now, do you want a sky? Do you want a sunny sky, intermediate sky, for mid-season, winter, or a uniform one? It depends on what you want. So in this case, you want a sunny sky using the CIE clear sky model. So you can represent, remember, that kind of like equinox and solstice. So 9 in the morning, 3 p.m. And so you can kind of set up one of the defaults that you have here. Later on, you generate the levels at which time. So again, because you want to perform, at least specifically for lead, you need to perform at 9 a.m. and 3 p.m. and compare. You can use the current date, current time, and then define it right here for, also including latitude and longitude and time zone. So that's already given here. All you do is pretty much choose it. Once that's done is what else, how do you want the image to be output as far as pixels? You want all the interiors, the exterior views, and so forth. It depends on, for daylighting, because you're working on the inside, you want to go with the interior views in this case. And finally, you select the cameras you want to analyze for every occupied room. So the idea is to see how many areas that are occupied have the amount of lighting that meets the requirements, and let's say for this lead-specific requirements of a minimum and maximum light level threshold. So you can use it based on lux representation, based on foot candle representation, and so this is kind of every camera of cameras for every room that you see selected. And the good thing is that you can see this in plan view, but it also helps seeing it in 3D, and that's the purpose here. Also, how accurate do you want it to be? The more accurate, and that includes every single area of your model. So it means that you can have very high detailed models that have, cornices, molding, you name it, that may actually, have some impact because of their material. The more accurate you go, beyond medium, you're going to see that it's going to take a little bit more to process. So it depends on your computer and how much time you have to generate the results. Usually they're pretty fast, depending on the building, of course. That's why sometimes it's good to subdivide your model to analyze it in several areas, in separate pieces. So a good workflow in that case, when you have a very large project, is to section it in quadrants and then bring those pieces into Ecotech as whether a GBXML or a DXF, and then analyze those areas and then compile the data at the end. So it's something that it won't allow you to take forever to process any calculation, and so you make things achievable on time. Anyway, in the end, what it's going to ask you is to save it as a Radiance output, and it actually asks you for the Radiance installation. You're going to see everything looking green, as you see here, check marks, when everything is installed properly. Now, if you don't see it, which is probably going to happen if you don't have it installed or install it wrong, then the first thing I recommend is on this website right here, you'll find not only the actual Radiance, desktop Radiance. If you're interested in the presentation, just feel free to shoot me an email at the end. I'll leave my contact info. But you can also Google it online, just desktop Radiance, and then you'll find the link. But just make sure that you install it. There's actually a tutorial on how to install it, because it's going to even prompt you for a password just to unzip it. So anyway, once you do, it's going to ask you, like I said, for the password to install it. It's going to tell you where you want to install it, which is the file that you wanted to install it from. And within Ecotech, you just path to the Radiance executable, and that's it. And of course, all of that is documented on the desktop Radiance website. Anyway, once you are done making sure that Radiance is built in and passed to the right location, then you just review everything that was explained on the last 8 steps that we talked about, everything from the output options to what's going to be run, et cetera, et cetera. Now, one of the things you're going to see is that you can generate point data. So that's something important that you want to use in case you want to bring in this information back into Ecotech, to use the Ecotech's grid feature that allows you to place grids in separate areas of the room. And that way you can get the actual validated information from Radiance that includes everything from multiple bouncing and reflectance of all materials and the orientation of the lighting to be used in a very easy and fast way to represent it in Ecotech. You'll see. So this is an example. Right here, this is the Radiance image viewer. So what it is a way to see the different images, different cameras, and represent the information as overlay data. So you can see that you can change the exposure level. You can see that you can represent this in daylight factor. You can see false colors. You can see contour lines, contour bands, and so forth. Now, for the purpose of the actual practical workflow for something like LEED, I would definitely recommend doing the contour lines, which I'm going to show you in just a second. That way, those contour lines, if you export the view from Ecotech as a Windows meta file, you can bring it into AutoCAD and create hatching that will give you square footage realistically that you can use to define how much square footage of lighting you're getting overall in that occupied space. You'll see. So anyway, so these are other representations that you can see in regards to, pseudo color, lux level based on dots, and those dots are representing different areas that you click on. So this is pretty cool because you can actually click on the image itself, and as you're clicking, it will just demonstrate the amount of foot candle level that is coming in that particular area of your image. So very, very kind of interactive and easy to represent. So overall, if you want also, it was going to provide you with close to real representation as a rendering. So you can use this, I wouldn't say it's a visualization tool, but it will give you a very close to accurate representation for lighting studies. I know actually quite a bit of lighting designers and manufacturers that use Ecotech and Radiance to present, test their information in the IS data within the lighting fixture, artificial light, and see how much light is actually needed in a room, and if changing maybe a particular light fixture to another one is going to make a difference in terms of less lighting or more to fill the space. So anyway, in the end, it can be used even for that kind of purpose, to just visually see an accurate representation of how light will be. But it's more on the interior lighting representation. I just wanted to mention it because it's something that is capable of doing. Radiance has an engine that produces a physical rendering. In the end, if you want to, you can open Radiance control panel that is more of a command line based. So you can type in a lot of information. You can preset properties on different palettes, and it's very user friendly. I mean, it's just a little bit. It's not as pretty as far as the way that you can visualize things in Ecotech, but you can change a lot of things the way you change properties in Revit, for instance, or in AutoCAD as far as filling out the different parameters. Anyway, in the end, how do you use this data, just since we're running out of time, how do you use this data in Ecotech for real practical use? Well, first of all, you can that data from the analysis now can be displayed in Ecotech. The 3D volume can be displayed by setting upper and lower thresholds, and I'll show you in just a second how that looks. You can now interrogate the 3D volume by slicing any location in different axes, so you can see how much light it is by doing kind of like a 3D section. You can extract surface data into the center and surface normal of different patches, and you can process multiple images so you can view a different range of different values. What does that mean? Well, this is what I mean. So you can split your image and view it as a volume and kind of visualize it in a legend where you can see the amount of light coming in. It's a more visual representation. It gives you a better idea. Also, you can see it in a grid or visibility analysis where you can see the percentage of daylight or the full candle level, lux, depending on the value and the units that you use for calculation. And finally, you can see even on a more expanded, a broad area. So you could see that you have, on the urban side, how much lighting is available kind of on that whole spectrum. Anyway, so this is now using the data for real representation. So this is an example, and with that I'll conclude the presentation. You have, for instance, a particular room, and this is something you can do for the whole house, you can do, or for the whole not residential building, it could be any kind of project, but for the whole area, this can be used for commercial interiors, for instance, where you can have, you can calculate the amount of lighting maybe based on your interior design. So here's a representation for 9 a.m. where you can see the overall illumination, and then that's the way that it's going to represent it. With Radiance, you can see the lux representation in contours. So what happens with those contours is they're telling you the threshold between, let's say, a particular lighting value to another lighting value, like the lead requirement that it says 25 to 500 in an occupied area. Well, what do you do with this? You export it as a Windows meta file that you can do within Ecotech, and what that's going to allow you to is open that as a vector object in programs like Revit or AutoCAD, where you can now easily generate square footage. So it means that now you can hatch it pretty much, and then based on the hatching, you can see the range of illuminance and the regularly occupied area, and then kind of create your own legend in color, and then you can generate a report. And although it's not just a simple you fail, you pass, it's actually accurate, and it can be used for submittals if you want to for lead daylighting credits. I know that this method has been used by a couple of consultants that I know, and it's actually very, very, very creative and it's proven that it works. And like I said, it's something that you can validate. Radiance is a validated tool. There's white papers on it, so you can show you kind of what happens behind the scenes. But in the end, what you do is it kind of requires the reverse engineering, where you get the output and then you bring it back into your design tool, and then you manually just hatch it. And then, as simple as that sounds, that way you can now find out what is the total square footage overall of occupied areas that have access to daylight on meeting a particular threshold. Based on that, you see that if 90% of all your rooms meet that requirement for LEED 8.1, you pass. So based on that, you can see that, you know, beyond 90, that you pass. Below 90, you fail. So right now, you see an example here, 79.2 and 22%. That means that doesn't meet the requirement for the amount of daylight available for that occupied area. So pretty much in the end, what I want you to take away from this presentation is that Ecotech has its own tool, can perform this kind of daylight simulation, and is a very intuitive and easy to learn tool, and it works very well with your design package. But then, in order for you to make it more, I would say, you know, more accurate in the way that it interprets the results and the way that you can actually validate it and prove it, is to use programs that are defined for that, to take advantage of certain kinds of particular areas that Ecotech doesn't take into consideration. So Ecotech in this case serves as a visualization platform for data generated by Radiance. However, it can also be used to generate the model, export it, control the run, then import the results, thus making the use of Radiance much simpler and easier for the more casual user. Combined with free Radiance control panel and the Radiance image viewer, which I show you, it pretty much provides complete development environments where you can start testing things. So again, I can only tell you so much in the amount of time that we have, so I want to leave at least some room for questions if you have any.
Yes, a great presentation, by the way, Leo. There's a question here that says, does desktop Radiance have compatibility issues with the recent version of AutoCAD?
Desktop Radiance with the recent version of AutoCAD. In regards to the format, when you I've tested 2012 DXF, and I haven't had any problems bringing in the format into Ecotech. In regards to running the simulation, once I have the DXF and I set up the grid, the idea is to bring it directly, bring it into Ecotech to perform the calculation then in Radiance. So as long as you can bring in the geometry into Ecotech, then there shouldn't be any problem. Not sure if there was a complication or a particular part of the workflow that was taken and that wasn't giving you an issue. If you do have a more, maybe something that you tested that didn't work, you can feel free to shoot me an email, and then we can explore more of the issue, if anything.
Great. I hope that answered your question. And there are no other questions right now, but if any of you think of anything from this webinar today, please email us at that email address that's Leo Salce at Microdesk, or you can contact us at webinars@microdesk.com. That's webinars with an S at microdesk.com. Thank you, Leo. Thank you, everyone, for attending today's webinar. We hope you found this helpful and educational. On our website, you'll see there's links to free webinars, events, classroom training, and other valuable resources. Leo, you can leave this up for just a couple of minutes just so anyone can take that information down. And once again, thank you, everyone, for attending today's webinar. We hope to see you at the next one. Bye-bye.